各位线上的观众，欢迎回来。我们刚刚听完微软 CEO Satya 跟我们分享的主题，包含 COVID-19 怎么影响到全球，还有微软在这一波怎么去因应。还有他最后提到了每一家公司都在未来都是科技公司，都要注意科技密度这件事情哦。紧接着我们进到了这个第二段，我们可以连线到这个微软，邀请这个微软 Azure 微软云的 CTO Mark Rosenvich 为我们分享他在看到这个 Azure 怎么做世界的变化，还有怎么去演进，看到这个 Azure 最新的进展。我们进影片看 Mark 怎么说。
Hi everyone, my name is Mark Rosenvich. I'm Chief Technology Officer of Microsoft Azure, and what I'm going to spend with you today is taking a look at Azure, which we consider the world's computer. Where does the term world's computer come from? What does it mean? If we go back a couple years, Satya introduced Microsoft's worldview, intelligent cloud, intelligent edge, where we're looking beyond just large-scale public cloud data centers to edge computing, the infusion of computing in the world around us. And that includes, of course, our PCs, our phones, but also the embedded computing in buildings, in factories, in cities, in oil wells. What we mean by setting that worldview is that we strive to provide a platform in Azure as the world's computer that is consistent across large-scale public cloud data centers all the way to the smallest of IoT devices as much as possible. That consistency including management, security, identity, monitoring, management, application models, and programming models. Before I talk more about how we're fulfilling that vision of intelligent cloud, intelligent edge, I'd like to spend a few minutes talking about the ways that Azure differentiates from other cloud providers. We focus on four primary pillars: productivity, trust, hybrid, and intelligence. And with each one of these, we've got differentiated solutions, and the combination makes us truly differentiated. Let's spend just a minute or two on each one of these, where I'm going to highlight examples of how we differentiate. The first being productivity, where more and more productivity for enterprises means open source technologies, whether it's Linux at the foundation or leveraging an open source container orchestrator like Kubernetes. Azure's been focused on supporting open source for many years now. And we've got a portfolio of support for open source, including multiple Linux distributions from Canonical, Red Hat, SUSE, and more, all the way up to higher level frameworks and languages, including some truly unique partnerships with open source community, like our partnership with Red Hat, where we jointly operate Azure Red Hat OpenShift, a Kubernetes service that's built on our own Kubernetes service, Azure Kubernetes Service, or AKS, to Databricks, the company behind Spark, a popular framework for machine learning and data analytics, where we operate a service jointly with them, Microsoft Azure Databricks, where you get the best notebook and Spark experience on any public cloud. But Microsoft's focus on productivity also goes into tooling. Microsoft's been focused on tooling from its very birth as a company. And today, our support for tooling and development extends all the way from the development, from the programmer entering their code in an IDE with Visual Studio Code, the #1 IDE on the planet now, fully open source, in fact, the #1 most active open source project on the planet, and now adopted by companies that were never even before interested in anything from Microsoft, to Azure DevOps, the world's #1 CI/CD platform as a service, which provides you the ability to create build pipelines, integration pipelines, as well as release pipelines, to GitHub, an acquisition we made about a year ago, the place where open source developers collaborate, home to now more than 40 million open source repositories and 44 million active developers. Microsoft making GitHub do more of what it does best, which is open source collaboration. In the last year, we've made a number of enhancements to GitHub, like GitHub Actions, which allows you to create CI/CD workflows on top of your GitHub repositories. If we turn our attention to trust, Microsoft's got a long history of trust and understanding enterprise requirements in security and compliance. Azure demonstrates that with its certification coverage, the most of any public cloud, over 90 certifications spanning global, US government, industry standards, and regional certifications. Microsoft Azure also has the deepest coverage in certifications, where deep means the number of services that meet these certifications. Each of these certifications represents hundreds of security controls. They're a reflection of the fact that we produce evidence that we adhere to them, that give customers and regulators the trust to place their workloads and data in Microsoft Azure. But that focus on security controls extends to the support for keeping your environment and our environment secure. Microsoft follows a first party equals third party principle for security. One of the tools we use to secure infrastructure is Azure Security Center, which we make available to customers. Azure Security Center will look across your Azure resources, notify you of when you've got security gaps, and even make recommendations for how to address them. For many of them, you could address the recommendations right from in the Azure Security Center portal. For example, if you're missing just-in-time access control on your virtual machines, you can simply select the toggle to turn them on to your virtual machines and mitigate them immediately. And what's even better is you, with the guidance of Security Center Secure Score, are guided to prioritize the security enhancements, the gaps that you close, where Secure Score ratings are provided for each mitigation so that you can go after the ones that boost your secure score the highest. And that also gives you the ability to track over time how you're improving the security of your service. Now, turning our attention to hybrid, if you take a look at Microsoft's focus on hybrid, it's been there from the very start because we've understood that enterprises, as they move to the cloud, whether it's fast or slow, want a consistent experience with their on-premises resources and their cloud resources. We've got many foundational capabilities that support this hybrid posture, including, for example, Azure Active Directory integration federation, so that with Active Directory on premises, so that you as an enterprise, if you're using Active Directory, can have your users sign on to your local resources and have single sign-on to cloud resources like Azure, Office 365, or thousands of third-party non-Microsoft SaaS and PaaS solutions. We've also got focus on bringing hybrid solutions in integrated systems like Azure Stack Hub, where you get a full Azure from the Azure portal to the Azure control plane, Azure PaaS services, and Azure infrastructure onto as little as 4 servers that you can place within your data center and operate in a fully disconnected mode. To Azure Stack Edge, an edge data storage appliance that comes with compute capability for containers and virtual machines, where you can deploy workloads from the public cloud onto it. Azure Arc is our latest enhancement to our hybrid capabilities, where Azure Arc extends Azure's control plane out to resources that are outside of Azure. Our first resources that we support with Azure Arc include virtual machines and servers that you can then manage from Azure, Azure Kubernetes clusters that you can measure from Azure, and SQL analytics clusters that you can also manage from Azure, all as if they were part of your Azure subscription, but operating in your own environment, either hybrid or the edge. And then finally, our IoT solutions address those billions of IoT connected devices with a runtime that connects up into Azure IoT Hub for control and monitoring of your IoT devices, to Azure Sphere, a small device demonstrating first-class security with following the 7 principles of IoT security, providing such value and differentiation that companies like Starbucks are placing them in every one of their stores. Starbucks is using them to connect their coffee machines up to the public cloud so that they can monitor those machines for problems, as well as download new recipes to the coffee makers and monitor the quality of the coffee that they produce. And then finally, intelligence. The intelligence cloud, intelligent edge, is machine learning and AI, and Microsoft's been working in this area for decades now, primarily in support of our Bing search engine, where Bing, when you use Bing, you're looking at images, you're translating text from speech, and a lot of the breakthroughs that we have in these areas are driven by our Microsoft research labs around the world, including in China. You can see our Chinese Shanghai and Beijing labs are responsible for some of the key breakthroughs that we've made on machine translation human parity, going from Chinese to English and English to Chinese better than humans can do it. Those innovations flow into our cognitive services, our APIs that serve up these models. For example, you can call an API passing it an image and it will return back to you what objects are in that image. And we go further than just the standard APIs. You can customize most of them. For example, the image API, you can customize with as little as a couple dozen images to understand your own specific images that are relevant to your business. And then you can deploy an instance of that API that your applications can call. More and more, you're seeing us provide you the ability to take those APIs and package them as Docker containers. Once they're packaged as Docker containers, you can take them and run them outside of Azure, in your own data centers or on the edge. One of the examples of why this is so critical for many of our customers is the data needs to stay on the edge, either because there's so much of it that the bandwidth or latency can't tolerate going to the cloud, or privacy concerns make them want to keep the data on the edge. For example, we have retailers that are running machine learning models in stores so they don't have to send the video up to the cloud, and they can keep their customers' video in those stores and keep it private. And if you're not able to use one of our pre-trained models, you can always turn to our machine learning platforms, which includes Azure Machine Learning, which brings MLOps to machine learning so that you have an enterprise CI/CD type of workflow, you understanding the provenance of the data, understanding what models and versions and tests have been run on those models to make sure that they perform well in production. And we have support for training those models on top of diverse frameworks like PyTorch and TensorFlow, the two leading open source frameworks for machine learning, as well as to deploy those models or train those models on the latest and greatest machine learning hardware, whether that's the latest NVIDIA V100 GPUs in our DC-V3 series, 32 gigabytes, 8 GPUs clustered together with NVLink for massive performance GPU model training, or FPGAs or CPUs. Now that I've gotten a little bit, given you a little flavor for some of the differentiation, let's dive right into what's underneath the hood in Azure. And I'm going to start by talking a little bit about the servers that we deploy or inside of our data centers. Then I'll turn our attention to networking services, physical and software defined, talk about compute layers, Azure Resource Manager, and then I'll conclude with a look at what we're doing in storage. For each one of these, I want to give you a highlight of what those systems look like, and also give you a couple examples of innovations that we either have just released or have coming out in the future. So you can see that the cloud is rapidly evolving, and we're in the deepest wave of innovation that IT has seen ever because of this strong vertical integration from the software all the way down to the hardware. Now, speaking of hardware, the cloud starts with the data center hardware. And let's take a look at some of our data centers. First of all, Azure is a global cloud, truly the world's computer in the sense that we've got more and more regions, 58 and counting, all around the world, multiple in China as we continue to expand. And when we talk about those regions, we talk about them in the context of geographies. Geography being a boundary where customers are happy having their data reside. China being one, for example, geography. Within those geographies, we'll create two regions. One region that will have availability zones, and another one that can serve as a disaster recovery site. In some cases, depending on the size of the regions, we might have all regions, or the geo, all regions with availability zones. But with availability zones, what you get is the ability to tolerate localized failures, failure like a flood in the data center, or even a flood in the local region. A flood that won't impact more than one of those availability zones, where the availability zones are made up of discrete data centers that are separated typically by kilometers. They're close enough, though, that you can replicate data synchronously so that if one availability zone is down, for example, there's a flood or fire in the data center, the other ones continue to operate, and your services then continue to operate. That second region is a region pair, and it serves as a disaster recovery target. If something happens to the primary region, your workload can fail over. Again, looking at meeting the needs of enterprise customers that need high availability, as well as disaster recovery. What is exciting to me is really looking beyond the dots on a map and seeing what's underneath the growth of the public cloud. And our Dublin region is one of the sites we call a hero region. It's one designed to grow indefinitely, where you can see how the public cloud demand has led to the rise of data centers. Here's the initial footprint for Azure in Dublin, DB3 and DB4, data centers that were built in 2011, 2012 timeframe. Here you can see DB5 that came along in 2014. That site that you just saw, those 3 data centers, are up there in this larger picture of the Dublin area. And you can see that we've been building out over the last few years here, DB6, DB7, DB8 coming online in 2017, and we're continuing to build out in Dublin to meet demand for cloud. Here's the future campus works area where you can see land that's being cleared for additional data center capacity. Truly a hyperscale public cloud region. You may be wondering, what about impact on climate change with all of those servers pumping out carbon? Microsoft's commitment to the environment spans not just our data centers, but the whole company and everything we do. So we're one of the largest purchasers of renewable energy, whether it's water or wind or solar. We've made some of the largest deals in corporate history to procure renewable energy. But we've got a commitment that goes to not just ensuring that we're that we're offsetting our carbon production, but that we're actually completely eliminating it. And not just eliminating it now as we go forward, but also going back in time to pull out from the atmosphere all of the carbon Microsoft's ever put into it. This was a commitment, you can see Satya with Amy and Brad Smith, our president, that we made to go and become by the year 2050 net carbon zero, meaning we'll have pulled out of the atmosphere more carbon than Microsoft's put in since its founding in 1975, not just in terms of data centers, but also our offices, our employee travel, and the suppliers that produce the products that we then put together into data centers or products like Surface Books. All of that will be offset as well. It was supported by $1 billion innovation fund to help startups and companies research new ways to pull out carbon from the atmosphere. One of the benefits of Microsoft is Microsoft Research. I mentioned it earlier in the context of machine learning, but we've got many projects with Microsoft Research where they're looking forward for us in the Azure product teams at ideas that may or may not pan out, but we expect to get learnings from. One of them that is really a showcase is Project Natick. Project Natick started a few years ago with the idea that perhaps with a lights out data center operation, we could prolong the lifetime of servers, thereby bringing down the cost of cloud computing. They took a look at this in the context of cylinders, where they place the servers into cylinders and evacuate all of the oxygen and water vapor from them, replacing it with nitrogen gas. And with that, and with lights out operation, meaning no human ever touches those servers, the premise was that these servers would last years longer with fewer failures than traditional data center servers. And with that, we could bring down costs. Further, being on the ocean floor, we could deploy these data centers very quickly. We could have them operate at constant temperature, no need for cooling because they're naturally cooled by the water surrounding them. And we could even power them with ocean currents. So about a year and a half ago, we took 12 racks, about 850 servers, put them in a Natick cylinder, and within 30 days of that cylinder being ready at the factory in Brest, had it turned on in the ocean floor a kilometer off the coast of Scotland in about 100 meters of water. It's been a year and a half, so we already have some insight into how these compare with our land-based data centers. And what we found is incredibly encouraging. The Natick servers have 1/8 the failures and faults of the land-based control servers. The servers taken from the same pool to make it a rigorous scientific experiment. So without a doubt, this lights off operation with nitrogen gas is having a tremendous impact on the reliability of servers. That combined with the agility we get out of deploying these containers and having all of this space basically to deploy them. 50% of the world's populations within just a few kilometers of the shoreline. We're proceeding on to the next phase, Natick V2, where we're going to take 12 of these, put them on a gantry that feeds power and networking to all of them, and drop that to the ocean floor. And with lights out operation, if one of the cylinders starts to degrade, the servers start to fail in it. To replace that capacity, we simply pull up that cylinder and replace it with a fresh one. So truly potential revolutionizing the way that data centers are operated, both on underwater as well as on land. Now let's take a look at our servers. Now for that, I want to take you a walk down memory lane back to the servers we were using in 2010, which is when I joined Azure. They were our Gen 2 servers. Back then, the cloud was considered commodity and scale out, and you can see that they had 32 gigabytes of RAM, they had no SSD, 1 gigabit of networking switch. But what we found out quickly as customers started to migrate enterprise workloads is that they wanted large scale-up servers as well. SAP, HANA, other in-memory databases require huge amounts of memory. And so we started deploying large servers, starting with our Godzilla server, our G-series virtual machine you might be familiar with. These servers had 512 gigabytes of RAM. They were considered monsters at the time. That wasn't big enough, so a few years ago we introduced Beast, going to 4 terabytes of RAM to support even larger SAP HANA migrations to public cloud. You can see that the Gen 6 servers that we're deploying in our mainstream fleet today, they're larger than the Godzilla servers were 4 or 5 years ago. We are now deploying both Intel and AMD servers so that we've got the best of both companies' technologies available to you. And it turns out that SAP HANA workloads are getting bigger and bigger, and our enterprise customers want to move those to public cloud, and so we've had to introduce bigger servers than Beast. Beast V2, or son of a beast. This has 8 sockets with 28 cores per socket, 12 terabytes of RAM in it. And we expect to even be bringing and building larger servers because our customers are creating ever yet bigger SAP workload deployments that they want to bring to the public cloud. Azure being the #1 place where enterprise runs SAP in public cloud. And I don't want to leave out Sphere. I mentioned earlier. Here's our Intel Gen 7 and AMD Gen 7s that we'll be deploying in the next few months. You can see the latest and greatest technologies from Intel and AMD. But Sphere, with just 64 kilobytes of RAM, wouldn't be visible in this chart without the help of this giant magnifier. And you can see Azure spans, as part of Intelligent Cloud, Intelligent Edge, all the way from tiny Sphere devices on the edge to massive Beast V2s in the public cloud. When it comes to innovation in servers, one of the places we're looking is to meet this trend of CPUs and GPUs, which are drawing ever increasing amounts of energy. Are those GPUs from NVIDIA, the latest ones, the Volta V100s, that come in appliances called DGX2s, 8 together, combined draw 10 kilowatts of power. To put that in context, a data center rack is provisioned for about 14 kilowatts of power. So that means we could, given current cooling, only put one DGX V2 appliance in a rack, occupying all of that space for just those 8 GPUs. This is pushing us to look at more efficient ways to cool our data centers so we can pack them more densely and make better use of the space. Here's our air-cooled servers. We're looking at microchannel cold plates, which is the liquid cooling that you might even have in your home gaming systems, liquid cooling that is going through plates that are attached to the GPUs and CPUs, to single-phase immersion, where we put the whole motherboard or main board inside of a liquid, to two-phase immersion, where it's a liquid that has a very low boiling points for extremely efficient cooling. These are technologies that we're working on and we expect to see in production in the not too distant future. Innovations that for an enterprise would be very difficult to go fund or deploy, but we're doing it in conjunction with the design of our servers, and so we can very quickly bring these technologies out and make them available. Another example is where we work closely with our partners, like Micron in this case, to bring you the latest and greatest technologies and even influence the way that those technologies are created to suit public cloud. In the case of Micron, we've developed a Scudi type storage device based off of 3D XPoint, a truly revolutionary storage technology that is like flash because it's durable, but also like DRAM because it's extremely low latency. And we worked with Micron to create devices that have the ability to partition the devices so that we can give pieces of them to different customers and have them get a great, reliable, performant, consistent experience on them. I'm going to show you a quick demo of Scooty in action. On the left, you can see a standard SSD deployment, a virtual machine with an SSD attached to it. On the right, one that has a Scooty device attached to it. And what I'm going to do is launch here a benchmark on each one of them that drives as much data to those drives as possible, as they will support. You can see this SSD supporting about 2 gigabytes per second, the Scooty device over 9 gigabytes per second. But how does that translate into real-world performance? For that, I'm going to run a SQL query, one from the TPCH benchmark suite, on each one of those systems. It's a 500 gigabyte database, and when I execute the query on the SSD, you can see on the left side the disk transfer seconds per transfer comes to about 20 milliseconds per I/O. And the query here, it just completed, took about 18 seconds. Now let's compare that with what we see on the Scooty device. So opening that same query now on the Scooty device, 500 gigabytes, and running it, you've got to pay close attention because it's completed. And the disk seek time, the seconds per transfer, is about 2 milliseconds. So about 1/10 the latency of what we saw on the SSD. And the total query, it took just 4 seconds as opposed to the 18 seconds we saw. A dramatic difference. Just one of the innovations we're working on with hardware partners like Micron. Now, let's take a look at Azure networking. And networking spans everything from the physical WAN to all of the software-defined services like DDoS protection, VPN, virtual networks, firewalls, out to connections with the outside world, whether that's the edge or enterprise networks through ExpressRoute and Express Route Direct, which support up to 100 gigabits of bandwidth that goes directly from an enterprise network into Azure's network. And that network spans the world. 130,000 kilometers of cabling, 160 edge sites, 500 network partners and growing. A network that we control our own from end to end. So when traffic enters our network and goes out across the world to another region, it stays completely on our dark fiber. One of the innovations we're working on in the networking is making containers. You might be familiar with Docker containers. Traditionally, containers have been implemented with what are called overlay networks that have nothing to do with the underlying network of the cloud provider. And that means that you're missing all of the cloud provider's features like the routes, like firewall rules that you can apply using cloud APIs. With Swift, we're bringing the underlay Azure SDN, Azure Software Defined Networking, to containers. And the way that works is by an agent that delegates a customer's network into the container orchestrator, like Kubernetes. So as the containers get deployed, they can sit in the customer's network, even though those virtual machines that the containers are in happen to be on top of the Kubernetes network. Let me show you an example of that in action. So first, I've got 2 virtual machines. I've got them inside of an infrastructure virtual network. Here I'm looking at the address space for this virtual network. You can see it's a 10 dot space, and when we see a 10 dot address, it's the virtual machine itself. One's at 10.4, another one's at 10.5. Now the customer network, where the containers are going to run, that one has a different address space. Its range is 172.20. So when you see a 172 address, that is the container. Those containers are going to run in those virtual machines. And we've got 2 flavors of those containers. one that's running in the virtual machine that has accelerated network or high bandwidth network, and one that's not. So you'll be able to see that they are, here we're launching one container in one virtual machine, the 172 address, and another container in the others. And these are sender-receiver pairs of containers in each of these virtual machines. They'll just send data to each other as fast as they can. One accelerated on the accelerator virtual machine, the other pair non-accelerated. And you'll be able to quickly see as they start to report their results, which is which, because the accelerated one is going to be driving much higher bandwidth than the other one. You can see this is about 2 to 3 gigabits per second, and that is not anywhere close to the 20 gigabits per second that we see on the accelerated network. And you can see that both of these are running inside of different virtual machines, delegated subnets, and so this is really giving first-class networking capability to containers. Now let's take a look inside of compute, and where compute starts with Azure is in Azure's control plane. Azure's control plane is called Azure Resource Manager, or ARM. And ARM is a universal control plane. Every Azure service plugs in. ARM provides every Azure service, whether it's Azure Kubernetes Service or Azure Key Vault or SQL, with common capabilities, with the ability to model them in templates, with monitoring for them, with role-based access control, and with Azure Policy. Azure Resource Manager provides consistent capabilities across all of them. And that's where Arc comes into play, is extending those consistent capabilities out to resources that are outside of Azure. Now, another part of compute is, of course, related to running compute workloads. And we're developing a next-generation compute fabric called Atlas that is highly optimized for running containers, because today, while most enterprises are running on virtual machines, in the future, the world is going to containers and container orchestrators. We've got a common container orchestrating platform, Atlas, that underlies all of our container-based services, whether that's AKS, Azure Kubernetes Service, ACI, Azure Container Instances, Azure Functions. All of those are moving to run on top of Atlas, which is based off of our own internal container orchestrator service fabric. We're also making innovations in making containers operate better, not just in networking, but also have higher performance. One of the challenges with large containers is that if you take a look inside of a container, they're made up of images that are layered on top of each other. And before you can launch or start the code that's in a container, you need to load all those images. And if for a large container, that can take a long time. With something called Project Teleport, we're making it so that those containers can start in a fraction of the time, because instead of loading all of the containers, we just simply mount those images on file shares. And once they're mounted as file shares, we can start executing without having to pull all the data across from the servers. They get faulted in on demand. And you can see dramatic differences. A dedicated virtual machine launching a 5 gigabyte container takes about 412 seconds to read in that entire 5 gigabytes. If you take a look at Azure Container Instances or serverless container offering, it takes a little longer, because that's a multi-tenant resource aimed at high-density containers. Now with Project Teleport, that 412 seconds turns into 7.6. We're also looking at the next generation of cloud-native platforms. So writing a distributed application is extremely hard. There's so many things you got to worry about. Different SDKs to integrate with, for PubSub, for state management, for service discovery, as well as having to deal with all of the issues with how do you route, how do you do retries and backoffs. All of that is work that the enterprise developers would rather just have the platform take care of so they can focus on solving their problem. But today, the challenges in delivering something to address their needs range from the fact that they're being asked to develop these resilient services, microservice-based apps, but they write them in many languages: Go, Rust, Python, JavaScript, Java, C#. And when they're writing an application, they want to leverage a lot of existing code, not just write it all from scratch. They're also, when you take a look at what enterprise developers have really resonated with, it's actor models and functions as a service. Functions being event-driven, serverless pieces of code, where the platform takes care of all of those distributed systems kinds of problems about failures and retries and scaling for the developer. So we've introduced and we're working on the next generation cloud-native programming model platform called Dapper for Distributed Application Runtime that is aimed at solving the needs of enterprise developers. I'm going to show you a quick demo of Dapper in action. I don't have much time to get into it, but this demo really highlights just how powerful it is. The idea here is we're writing a distributed app calculator, one where every one of the calculator operations, plus minus division, is represented as a different microservice. First thing we do is take advantage of Dapper's sidecar, which is represented as an HTTP interface. We can talk to Dapper through that interface, and we can do things like tell Dapper to save state, like what is the current state of the calculator. We can just call an API there on a local endpoint and save the state. But you can see we can also call Dapper microservices using these different Dapper invocations. Subtract, just by calling the subtract microservice through an HTTP request. And for each one of those microservices, like here's the addition written in Go, it's simply a web server that's integrated with Dapper. So Dapper will call the Go web server, passing it the request. It simply adds the inputs together. The subtractor, same thing. Dapper will call it, and with the subtract. Here we see a multiplier written in Python. You get the idea. This one's got a Flask web server, and that's the entire code for the microservice. Here you see a divider written in JavaScript. And that front end was simply calling these Dapper microservices. Dapper worries about where they are because these are going to be deployed on Kubernetes. So they'll be in containers on different servers. Dapper worries about getting the request from the front end to these different microservices. So speaking of Kubernetes, here I'm going to get pods, and you can see I've deployed the application, and we can see the Kubernetes pods for the adder, for the front end, for the divider, for the modulo function, for the multiplier. The modulo is written in Fortran, just to show you that any language can integrate with Dapper. That is the entire app you're looking at. That's a few hundred lines of code in 5 different languages. And what I'm going to do is now open up that calculator by going to its URL. I'm going to show you on the right side, you can see the logging of the Dapper calls to save state, to perform those different operations like add, subtract, multiply. I'm performing a bunch of operations. You can see I'm going to leave here the calculator. There's the state is 1. That's the current state. I'm going to refresh the web page here, and you're going to, in a second, and you can see that it remembers that its state was 1 by calling into Dapper and saying, what was my state? So externalize the state to Redis cache in this case, or Cosmos DB, or whatever. You can see we get, because we're on Dapper, we automatically get tracing. So you can see the invocations from the front ends to the different microservices, including how long they took. This is application insights built right into Azure. The data was collected by Dapper and forwarded. So with no work on the developer's part, we get full insight into the way the application ran. And then we can also look at the list of operations discretely. So Dapper really represents a breakthrough, we think, in the way enterprise developers can write distributed microservice-based applications. Now finally, I want to take a look at storage. And storage includes lots of different services from HDFS to NFS to SMB, all built on top of a common storage infrastructure that supports all different tiers of storage, from hot that would be sitting inside of SSDs, to cool storage on hard disks, to archive storage. I mentioned our work with Microsoft Research, and a few years ago we started looking at archival storage. How could we could make that cheaper? And the way that we're doing that is with storing data in glass. Glass, you might be wondering, what's the benefit of that? Well, if we can store data in glass, we can store it in 3D. We can store it extremely efficiently in what are called voxels, which store, when we write those voxels with femtosecond lasers, different bits of information using retardance and polarization angle. Each one of those voxels can store multiple bits. And by etching all this information in glass, we get the benefits of glass, which is it's extremely durable. You never have to rewrite it. It doesn't degrade. You can do things like boil it. You can degauss it. You can scrape it with steel wool even. Because the data is in the glass, not on the surface of the glass, like it would be for a Blu-ray disc or CD. You can even microwave it. And finally, you can bake it at high temperatures. Glass is extremely durable. It's also extremely cheap. It lasts for millions of years. And here you can see that we were able to read back the data that we'd written into that piece of glass that went through that extreme torture test. And we've partnered with Warner Brothers to store the movie Superman in a piece of glass and successfully read it back, a big milestone we announced at Ignite. This was going to transform the way the media industry stores their content, which is their lifeblood. Up to now, they've been storing it in analog form. Now they can keep it in digital form. They never have to reread it to like they would with the film that they were storing. And film decomposes if it's exposed to any of those tests that we exposed the glass to would be degraded. But here, the Superman movie is going to be safe for thousands or millions of years so that Warner Brothers can go back and re-release it, reuse all that content. Again, just one of the many types of innovative projects that we have in Azure and with Microsoft Research to advance the cloud and make it more powerful for you. So that brings me to the conclusion of the talk. I hope you found this interesting. I hope it gave you some insight into Azure's differentiation, hybrid, trusted, productive, intelligent, as well as a look underneath the hood at our data center, servers, compute, network, and storage, including some of the innovations that we've been working on. Thanks very much, and I hope to see you on Azure.
嗨，各位欢迎回来哦。Mark 刚刚为我们分享了这个 Azure 这一段，讲这个如果直翻他的这个话题，讲的是世界的电脑哦，他在讲云的这个概念。我们一般对于中文这个 computer 电脑这个理解，我们常常都是比较能够理解说，哦，它是一个计算机，很快的计算机。那最快的计算机，我们可能大部分用中文理解都知道是超级电脑。那他在仔细讲到这个什么是 Azure 云的这些相关服务的时候，其实提到非常多的细节。它的细节呢，我可以总结延伸了大概 Satya 刚刚最早讲的这个世界价值观，就是智慧云跟智慧运算，让所有的东西，不论从资料中心一直到边缘的运算，都能够让计算力无所不在。那要让这个计算力无所不在呢，在 Azure 上面，Mark 提到了4个非常重要的点，包含生产力，还有信赖的程度、混合云，还有最后能够让它智慧化。那在生产力的部分呢，其实就延续着我们昨天看到的这个 Kubernetes 的最新发展，或 Spark 等等的工具，还有微软也提供了 VS Code 啦、GitHub 啦，整合了 Azure 的 DevOps 等等工具，让他刚刚提到了一个让很多本来对微软这家公司都不感到兴趣的公司或者是人都开始感到兴趣了。第二件事情，他讲到的其实是信赖哦。那这边他提到了微软其实很重视合规这个项目，所以 Azure 的这一个云呢，其实得到了非常多的合规的认证，包含了有全球级的 ISO 啦、SOC 啦，或者是 CSA， 或者是区域级的譬如说 IRS、DOD 啊、NIST 等等的认证。那看起来像是很多认证的这个云的相关的 service 哦。那另外它也提供了安全中心的服务，统一让组织可以透过一个界面很快速的管理跟部署资讯安全，注意到说服务有没有遭受到什么样的威胁。那在混合云部分的方面呢，昨天我们提到了，当企业或者是组织要选择使用云服务的时候，会考虑到它是在云端或者是在本地端资料中心两端，它都要有办法可以部署它相关的资源。那要部署相关资源，还要能够无缝接轨，用中文来翻译，简单来说是这样。那它要整合超级多不一样的服务，才能够让本地跟云端同时能够整合。这部分 Azure 做了非常多的跟开源社群的合作跟努力哦。最后一段我们看到就是微软事实上在人工智慧也投注了超过20年以上的时间，我们有非常多朋友都是 微软研究院在出身，然后在做这相关研究的。现在很多这个微软相关的服务，包含了认知服务，例如影像啦、speech， 或者是翻译，还有对话啦、搜寻，还有知识图谱等等，都已经能够透过 API 去调用，而且支援非常多不同的程式语言，还最后可以让你透过 Docker 这样子的工具封装在容器里面带着跑。那事实上，对于一般的企业来说，选择这些应用怎么去应用这些资料，选择这些云服务，事实上是有一些想法的。那Mark 其实在后头也接触了非常多微软的 Azure 现在正在做最新的研究，包含了跟美光合作储存的这些设备的更新的特性的研究，还有微软之前其实有公布过，他们正在研究是不是要把资料中心放在海里。那他提到这个计划已经进行了大约1年半，接下来做完这相关的研究，效果看起来不错，所以会继续下去，有2.0的版本哦。另外后面也提到了，包含譬如说在资料中心要快速演算的冷却啦，或者是甚至在网络上面的投资啊，都有更多的进展跟发现。甚至我们看到了一个新的 project 叫 DARPAR， 其实可以用任何语言或任何框架去建立 APP， 这件事情是我们所有做开发者的梦想。那我想，各位听到这边，其实会看到非常多很多不一样的这些技术在演进，而且这一次 Azure 的更新其实是非常令人惊艳的，甚至在这里面有很多都还是目前在新闻上还没有看到微软的 Azure 最新的这些研究的进展哦。我想问这个 Tyan 刚刚在看这整段直播的这个过程当中呢，看到微软呢在投注这么大量的资源在建立 Azure， 甚至在转换这个 Azure 相关服务，从软体开发框架一直到硬体资料中心、储存设备，甚至暗先，就是他做了非常多他们资料中心跟资料中心之间的投资。那这些投资对于企业或者是我们台湾的公司来说，或者是组织来说，这代表什么意义？然后我们应该怎么去看待他做这件事情？
好，那我认为这个微软这个 Azure 这个平台啊，那未来在运营会有2大层面的一个 issue， 一个是软体的层面，另外一个是硬体层面。那我觉得硬体层面是比较大的。第一个是说我们在大型服务的时候，我们会有2个策略，一个叫做水平扩充，一个叫做向上扩充。水平扩充的部分，我相信现在的软体跟工程师其实大部分都已经做得还不错了，但是在未来，在这个空间跟网络这个物理的限制的状况下面，其实向上扩充是接下来云服务跟数据中心会面临到一个比较大的问题。那我们可以看到在Mark 的介绍里面，可以在很多的部分着重在硬体，可以看到它不管在网络速度啊，在 network 的这个扩充。我们在这次疫情可以看到说，我们目前的整个流量上升的有上升到600%。那就传统的这个水平扩充，其实物理限制是没办法突破的。那现在微软的这个这些计划，其实它就可以有效的去做一个向上扩充的一个支持。所以我认为这个整个具体代表意义是，微软在这边会长期的投资这个环境，并且提供企业更好的一个运行的一个环境。对。
所以其实很多新技术的发展不是为了现在而已，是为了接下来的未来所有的需求，那些突破现有的物理限制，能够进一步再往上前进的这些动作。所以为什么微软做了怎么样的多的这个服务，跟这么多的研究跟更新哦？那第二个问题，我想要回到你的老本行，就是我认识你最开始的时候，我们在社群里面常常会谈到的问题，资讯安全跟合规这个问题，其实对于所有的公司来说，在平常听起来好像不一定要那么注意，除非你被勒索，今天跟你要虚拟货币或等等其他的方式，或者是你的服务受到了攻击，导致于你的服务被中断了等等的。可是事实上这件事情非常重要。那我看到这个微软有一个特征，就是在这个 Azure 里面，他刚刚在解释的时候，他其实非常强调合规这个项目。我们也看到事实上Azure 做了很多努力，在不管是全球级或者是区域级，甚至在一些不同的环境里面的这些合规或认证哦。那企业在选择云上面呢，你如果以你的经验，不管从资讯安全、从 GDPR 的角度，或者是从这个合规的角度来说，你会建议大家企业要特别注意些什么？
OK， 在现在的云服务，我觉得在不管在认证或者是在基础的云的一些安全的架构，基本上大家都有琢磨。但我觉得接下来在全球化的过程有几个重点，第一个是全球化的这个趋势，全球的合规。所以看到微软它针对于 local 的这个合规，它有一定的作为。那举例来说，像我们之前在欧洲，我们想要做一些数据的一些我们要做一些服务的运营，其实它对数据就有所要求它可能会要求说资料一定要在当地落地。那这个部分微软它就提供了这个当地的法规，甚至当地的运营中心。所以我觉得第一个重点是在商业运营层面。当地的法规会是一个比较大的议题。好，那在第二题是，我觉得在资安到运行到现在的过程中，资安慢慢有一些变化。我们应该是说下一个升级，这个升级是我们叫做资安的主动运维。那这边做的事情是这样，我们在开发的安全性这边已经琢磨很多了，但是在运维的安全性，第一个我要能知道说现在既有的服务里面用了哪些服务，这些服务有没有弱点。那以往发生比较多的问题就是这些配局这些更新晚了一点上被骇客利用，所以主动的侦测是第一个。那第二个在运营的安全还有一个就是我侦测到了，我可不可以主动的去更新？那微软在这边的界面其实设计的也有一些作为，所以我们在上面如果发现了，我可以提早的去做更新跟配局。对，那我觉得这两个是比较大的层面。那在最后一个比较延伸的是说，除了两个比较云端的部分的安全以外，还有一个是接下来 Edge Computing 的端点安全。那在端点安全，我们在 IoT 更多的状况下面，其实这边的管理也要纳进到我们云端的控管，那它才能一个比较全面，从商务的运营法规，从线上的运营的 security 主动侦测到配局，然后到最后面我们把端点纳进来。那我觉得是接下来云端会比较重要的一个部分。
所以你提到了其实有3个大的环节，第一个是我们很多服务现在其实不是只考虑 local 了，是考虑 global， 甚至考虑在不同的环境底下都要能够运作。然后所以第一件事情是能够在不同的地区合规，这件事情蛮重要的。第二个事情是在讲到资安的时候，我们已经不是被动在防御了，是希望能够透过主动的方法。那这部分微软做了这相关的措施，所以帮助了运营的人可以很快速的去反应。然后最后一个部分我觉得蛮有趣的就是我们自己其实都知道物联网这件事情非常重要，但是在端点或者是说边缘运算上面，我们常有时候会忽略了其实它也有安全性的 issue。那在这部分事实上也需要投注相关的心力，选用相关的设备或者是相关的服务来处理这些问题。我想这都是非常好的建议大家可以思考一下说，看到这么多不一样的这些 service 的时候，事实上企业在应用这些不同的工具，或者是选用不同的企业级的这些智慧化的设备的时候，要注意哪些事那紧接着我们等一下会再邀请这个微软的 CVP 来帮我们分享有关 Power Platform 的最新进展。那我们先休息一下，待会回到现场。